All right, welcome to Bite-Sized Chemistry. Today we'll be talking about energy graphs. And energy graphs are representations of what happens in a thermochemical reaction, and they can tell us a lot about whether a reaction is endothermic or exothermic. So there are two types of graphs that you're going to encounter. Mhm. And they're both made up of the same parts. So on the x-axis, you'll have like reaction rate, or how fast the reaction is progressing, or the amount of time it's taking. And on the y-axis, you'll have energy, or the amount of energy. The higher on the y-axis the point is, the more energy it is. And then you're going to have one of two graphs. The first one looks like this, and the second one's the opposite. Okay? Now, those two graphs are made up of the same three parts. So the first part is the reactants. We're going to abbreviate it as R. So R is reactant. And reactants are the chemical compounds that you start with. Then you have what we're going to abbreviate as P, the products. And the products are what you end with, okay? After the chemical reaction. It is the result. And then you'll have this little like bar here, okay? And we call that EA, or activation energy, right? And it spans the distance between the energy level of the reactants all the way to the top of the hill, okay? So we'll call this EA. And that's called activation energy. And this is the energy needed to start the reaction. So those are the three main parts of these energy diagrams. Now, where we get a lot of information from is for looking at where the products are energy-wise related to the reactants. So in this first example here, so example one, we notice that the energy of products, so energy of P, remember P is products, is less than the energy of reactants. And what that means is that heat was given off. So heat is released. And when heat is released, we call this reaction exothermic. These reactions tend to feel hot to the touch, okay? Conversely, all right, conversely, if you see that the energy of products is greater than the energy of reactants, we know that heat is absorbed. And when that happens, the reaction is endothermic. These reactions are cold to the touch, okay? And so as you can see right there, just by looking at the graph and looking at where the products are in relation to the reactants, we can determine whether a reaction is endothermic or exothermic. And by looking at the distance between the level of energy of the reactants up to the tippy top of the little hill, we can determine how much energy is needed in order to start the reaction. And that's all there is to it. We'll see you next time on Bite Size Chemistry.